Hey, welcome back to the Build It Basement. Today we're on episode number 15 on our Voron 2.4 build. If you haven't subscribed yet, please do so. Keep making videos so you guys can watch them, hopefully help somebody out. We're working on our AC power components, our mains, our line level power coming into the 3D printer today. Just to start that off, if you're not comfortable dealing with high voltage, if you're scared of electricity, this is probably not for you. We will be working with voltages in excess of 100 here in North America, and other places around the world you'll be in excess of 200 volts. North America, we work on 110, 120 volts. In other parts of the world, you're at 200, 220, 230. So with that, let's get started. And we're going to first check out our manual. All right. So in the manual, listed here is a two-part inlet and rocker switch design, which basically had the power inlet and a rocker switch in two separate pieces. The current version of the Voron and the one that comes with the Formbot kit is actually slightly different. It comes with, let's see here, get that on camera. It comes with this guy right here, which has the rocker switch built into the inlet. It takes up a little bit less space and allows for you to have some keystones on either side of that piece. I have it mounted on mine, and you'll see it in a few moments here, but basically that takes up the center, and then there's a keystone on one side, keystone on the other side. I've decided to go ahead and put a USB on one side of that, and on the other side I went and put an Ethernet jack. So I have Ethernet and USB on the back of mine. Not quite sure if I'm going to use them or not, but we'll see, right? So that is mounted, and that's using a couple of, where does that go? Some M3x8 screws right into the bottom of the rail. It's the only thing I have mounted on my bottom rail. I did not mount any of the skirts, try to make it a little easier to tape and probably a little bit easier to work as well. So from there, we're going to skip over this section with the fans and whatnot. We'll loop back around to that. Again, we're skipping over that simply for the reason of flow, allowing us to see what we're doing while we're doing it. So, and for some reason they show putting the bottom panel on before you do the wiring as well. Interesting. And a lot of other things here. So a lot of fun stuff there, but stuff we're not doing just yet. Okay, here we go. There are the major components. This is the SKRs. My kit came with a spider, so I'm doing a spider. Your Raspberry Pi, and your 5-volt power supply, your solid state relay, your SSR, and your 24-volt power supply as well. Mine is the same with the exception of, just the exception of the SKRs. So as opposed to two, I have a single board with all the outputs and inputs I need on the single board. We'll see how that goes. Our stuff is all mounted in a previous video. Skip over that as well. And here we go. And let's see if we can just zoom in a little bit, make it a little bit easier to read. There we go. I'll see here. You're about to start working with electrical wiring that can cause serious injury or death and fires. Mains power can kill and will hurt the entire and it will hurt the entire time you're dying from it. If in doubt, we encourage you to ask questions. Huh. I wonder how many people come back and tell you how much it hurt while they were dying from it. Interesting statement. This is not something you want to guess your way through. I totally agree with the statements. I'm not quite sure about the hurting the whole time you're dying from it thing. Maybe. I don't know. And I don't know if you died from it, how you're going to ask somebody questions about it. But nonetheless, I get the point. Hopefully you do too. So right here, green is representing, and I believe this is I know it's a North America thing. I assume it's an international thing, but green being ground. I believe there's yellows and blues used in other places in the world, but in North America, green is ground. Black is your line or load, and N is your neutral. Neutral and ground in fuse boxes in North America share the same endpoint in the fuse/breaker box, where your line is usually split into 2 poles. So you have a double 110 volts or 120 volts coming into your home or business, and basically that becomes one side, and then another side of the actual circuit breaker or fuse box. So you're actually dealing with a neutral and line. Ground is a protective wire, but that doesn't mean skip it. So first thing to show you here is the hookup of that switch and that inlet. And so basically on front side of that, what they're showing you is the ground being that pin, and then your line, your neutral. On the back here, just kind of show that off a little bit. And actually, let's just go with this. We have our ground, earth ground, and our neutral, and our positive or our load or our line. Those colors come across this way. These are all feeding into a switch. This is a lighted switch. It does require both power, neutral and line, to go into it to give it light. I believe it's a fluorescent tube inside this. It's not an LED. 2 reasons. One is LEDs would not handle that much electricity without some circuitry. And 2, I probably did it that way because fluorescent lights, old school fluorescent lights, don't require polarity. They'll work either way. One thing I do want to note on the back here is this guy right here, kind of scary. Slim to none chances you're going to touch that, especially if you know about it, but be careful. That basically is bringing your mains power from your connection point over to your switch, actually over to your fuse, and then into your switch. Now for the fuse, it's a glass fuse right there. It's a little tough to read, but not even, maybe the camera will pick it up. Probably not though. That's a 10 amp fuse either way. So 10 amp fuse in there, which is good. Should be plenty for the build, and also should be fine for near everybody that is plugging this into a wall. Most wall outlets in North America, again, are 15 amp. Some of them are 20, meaning that they will handle that amount of amperage going through them. So you shouldn't run any trouble running a 10 amp through those. So that's good, right? All right, so back to this. Ooh, slide that up. So here we go. Mains voltage wiring. So we have on the far right over here our connection point into the printer, and then we have our terminals going into the 24 volt power supply, as well as the 5 and the solid state relay, the SSR. So what they want us to do is basically bring our wiring down through, and they're all coming, they're actually using these endpoints as junction points for the other wiring. So the way this is done is semi-smart because, well, I guess it'll look 2 ways. The item that's probably going to draw the most electricity when in use is actually your solid state relay. That's going to be drawing, let's see, it says 110 volts, 150 watts. So it's going to draw about 8 amps, maybe 7-ish. Not going to do the math, but that's going to draw a pretty decent amount of electricity. Everything else in here, and actually, let me grab these right here. Everything else in here doesn't draw a ton. So our Meanwell 24 volt looks like input at 100 to 120 volts is 4 amps. At 200 to 240 it's 2 amps. So we got 4 amps there. And our 5 volt is the same across the board, 100 to 240, 0.7 of an amp. And there's no switch on this too. So make note of that. No 230, 110 switch on that. However, this does have a 115. Let me show you that real quick. Let's see if this will do it. So that shows 115, and switch to that, we got 230. So make sure you switch that to where you need it as you move forward. All right. Let me move this guy out of the way. We'll get to that in a minute. It's our heated bed. Now let's put these guys down. So I'm doing this off of the printer, more for ease of view than anything else. It's going to be pretty easy to route everything, but I figured this would be the easiest way to show everybody what's going on. I might go back there just to make some sizing real quick. So we have our leads on our power supplies. They have, and let me zoom in again. You have your ground, your neutral, and your load or line. And then here we have our ground, our neutral, and our line with a representative AC marking on there. And then a voltage negative and voltage positive for our DC. And then an adjustment pot right here, as well as an adjustment pot on this one. And then we have 3 outputs on plus and 3 outputs on negative. That's for our DC voltage. So we're using this as our junction point in the printer for jumping off of here and running our wires. Now, the Formbot kit did not come with anything that I would consider decent for wiring high amperage AC power. It came with a bunch of black silicone wire. It came with a little bit of red silicone wire, but none of that was really, or at least I don't feel gauged properly for what we're doing here. So because of that, I am going to use this wire. Now this wire, it was cheaper to purchase a small extension cord, cut it apart, pull the leads out. This is 16 gauge wire I'm pulling out of this. I think it was about $8 at the store, and I've got myself 15 feet of 3 conductor. Decent wire. It doesn't need to move a lot. It's not going to move a lot. So I'm not really worried about that. It does have a decent strand count on it. Let's just look at that real quick, show you. So it does have a decent strand count. It's not super stiff or anything like that. Extension cord wire. It's meant to bend around, get looped up, stuff like that. So if I wanted to buy spools of this wire, it was going to cost me about $30 a spool. So I didn't want to do that. I didn't need to do that. So I didn't do that. All right. So strippers. These guys work pretty well. If you prefer, or if you don't have some automatic strippers, you can use some of these guys. They're marked off by gauge on the side here. And then basically you just clip and pull. But these, very similar. Put them in. Does it in one shot. Ooh. Honestly, I don't think one's faster, quicker, or easier than the other. But these are handy if you have them. One less thing to deal with, I guess. You don't have to look at what you're actually doing. They automatically adjust based on the gauge of wire you're using. They're magic. All right, so I guess first things first. Now, I'm not quite sure why, but these are different lengths, and I don't like different length wires, so I'm gonna trim them all up to the same length. I guess that stripping thing was just for funsies. Pull them out and cut them back. Strip these off real quick. The other good thing about these, they have a little stop on them, so you consistently get the same amount of strip on them. So we got these little spade connectors in our Formbot kit, And it looks like I could use a little planning here actually, because I guess everything go off that screw. I don't think that these are going to handle the gauge of wire I have, is the only issue. Did pick up, we have some larger gauge units, but I don't know. Nope, I guess that will work. Okay. And then these will still just barely fit in there. Okay, so I'm going to use a slightly larger gauge spade terminal on these just so I can fit my wires in them. I don't believe I'll be able to fit them in these reds, and even if I could, it's going to be really tight. And I'm also going to top that off a little bit with some heat shrink, so I get that ready as well. Need it. And obviously you don't need them this long, so I'm gonna chop a couple of these up. Try to keep them about the same. So at this point, I feel like these videos are really dragging out, but my last live stream I did, people wanted me to continue doing it the way I'm doing it because I am going through every single step. I'm getting really antsy to run this printer, but gotta make people happy, right? So here we are. Hopefully everybody that needs or enjoys watching these is still having fun watching. I do have a pretty neat plan, or at least I think a decent plan for the heated bed, using some RC connections I have already and using this the things the Formbot kit came with. So when we get to that here in a few minutes. All right, so back to this real quick. So as opposed to daisy chaining, where we would go 1, 2, and then another 1, 2, and then another 2, we're basically unionizing all these into a single terminal, which is why I'm using the larger terminal. So we're going to have one go into each of these, and then 2 additionals come out. And then we're going to have those come out for right now as flying leads or unterminated ends. So then we can pull the printer up here and actually make them to proper length. So that's what we're going to do right now. All right, so we got 1, 2, 3, and actually I need to make these a little bit longer because we're gonna have to twist them pretty hard to put them inside those. We can always trim off the copper a little bit if we have too much. The only major issue with these automatic strippers are if you have a piece of plastic that sticks inside of there, they won't strip. You'll have troubles. So we're going to have, and we'll make these long. Not going to hurt anything. Let's do that. Make these an equal length to those. And it's probably a little asinine for me to try to make everything the exact same length, because in the end they will not. But for now, it'll help me keep my sanity. All right, so let's get these ones stripped as well. All right. So we'll start with the grounds, the green wire, and there's going to be 3 of them in that union. And we're going to start with them all together, like so. And what I want to do is basically give them a very good twist. Now, it may seem like it's a good idea to solder these, and if it wasn't for the heat in and around this printer, I agree that would be a good idea. However, because of the heat, I'm worried that the solder over time may crumble, basically through heating and cooling. We might need a little bit bigger heat shrink. Start to deform and then eventually get to a point where it falls apart, and if it crumbles after we crimp, that crimp is going to get loose. All right, bigger heat shrink it is. So we'll grab that. 1, 2, 3. All right. So I'm not going to solder them. Long and short of the whole thing. We're going to crimp them good and strong, and then heat shrink. As I'm putting them on, I'm just going to give them a little bit of a twist in the same direction that I was twisting the wire, just to make sure they don't unfurl as I push them in. So there we go. Now for crimpers, I'm just using standard crimpers. These are very much like what you'd find for doing your JTSs and things like that. They're just much smaller. You basically have an end that fits into another end and causes it to basically push into each other, causing a pinch point / crimp. Unlike a smaller connection, the biggest difference is we're not crimping the wire and the conductor separately. It's all happening at one time. That piece of vinyl on the outside is kind of protecting the connection that we make. Okay. That's pretty good. Yes. Once we get the AC done, not in this video based on the speed I'm going at, but very soon I'll be working on our actual DC wiring to our steppers and our end stops and just about everything else that's in there. There's another wire. That is going to be done, a majority of it off camera. Just like everything else, I try not to bore by doing the same thing over and over again. I'm actually feeling bad that you guys are watching me crimp 3 identical wires right now. But this is going to be pretty quick. We're actually not accomplishing all that much, but what we are accomplishing is pretty important. It's not going to work without it. There we go. All those are pretty secure. Good. Yank. Good. All right. Hit this heat shrink with some heat. Now you can use heat shrink with a lighter or a little torch or any other 1,000 ways of heating it up. I like using a heat gun. I don't like to overpower them. Heat shrink will actually overheat and then start to expand back out. Kind of defeats the purpose at that point. Another thing to note is I am extending my heat shrink a little further than I want to end up because it is going to retract, if I could speak properly. So once it does retract a little bit, it's going to be just about where I want it. That one. And our neutral, last but not least. This heat shrink is marine grade heat shrink, which means it has a very thin coating of, well, it's pretty much hot glue on the inside of them. It helps keep everything in place once they do cool off. It's going to take a second. They are a little bit stiffer, but again, none of these are moving parts or connected to moving parts, so it shouldn't make much of a difference. There's more of a benefit than a negative, I believe. All right, there should be enough for that. So, in order here. All right, so first one is our L. Let me... Yeah, there we go. Oh, that looks a little bit grainy probably because of the zoom, but doing it so that our spade terminal is basically, our wiring is showing up, the bottom is flat, the bottom is going in like this. Black being our line for L. Okay, and then N neutral. Again, with the flat section facing downwards. Screwdriver seems really magnetic. It's surprising because it's really cheap. There we go. Last but not least is our ground, which has a symbol of a line coming down and then 3 horizontal lines for earth, ground, or ground in general. So at this point we have our first connection point to our 24-volt power supply, and we have our power coming in. We have flying leads coming off of that to go to different points that we need to go. And where we need to go is to our 5-volt and to our solid state relay. So let me pull this aside for a quick second. Yeah, we'll put that there. Clean up a little bit right here. And let's bring the big boy up. Save those, save these. And then wires real quick. Pardon the mess. Here we go. All right. That's gonna be hard to see, huh? Let's see, where are we? What if we do? It doesn't help out much, does it? So adjust this. Maybe that works. I think that'll work. Looks like that'll work. Yeah, that'll work. All right. Solid state relay right here. The SSR. And since that is using the most power, let me see if this terminal fits in there. I assume the screw is pretty big. Oh yeah, perfect. Okay, we'll just leave that guy there for now. Okay, perfect. All right, so we are going to mount this back in. And to do that, kind of jump the gun, I'm gonna have to unwire this real quick. But what do you expect? You're doing half of this for show until sometimes you gotta do stuff more than once, right? All right, so we're gonna run our wiring back through here. And snap this in. And just to show what I was talking about, that right there is the newer design of the power panel. So we have our Cat 5 going in, we have a USB, we have our switch, and we have our power. Same but different. All right. This camera's not getting much help. All right. I think this is going to work. That should go good. All right. So we got this big boy right here. Since the junctions are all coming off of this first, let's put that right there. Right. And I'm gonna have to do this blind. It's gonna be fun. So our ground is going back into the ground, like so. And then our neutral. Our unbiased neutral. And then line or mains power. There you go. There's those three. All right, our flying leads. So we're only going to need a black to that, the green for the bed is going to go through one of these holes, as will one of these whites. So we'll do that for now, so we're not worried about those. That's going to go to the solid state relay, and then these are going to our 5-volt supply, which I believe is going to mount somewhere around here. Put that right in front of the Raspberry Pi. We can route the wires. Which way? Route the wires come back through this way, so yeah, that'll work. So let's pull this back and try to make these so they're not knotted. Leave ourselves a little bit of a service loop. Service loop basically is just more wire than you really need, not in excess to a point where it's horribly dangerous or anything, but just enough so that if you need to work on something, you aren't being held back. Oop. There you go. That's good. No, it's a little bit short. There we go. All right, 3 of these guys. And 3 pieces of heat shrink. Get back here. So we'll give these a quick twist. let's go back to this for a second while I'm talking. So right now we're hooking up the 5-volt, which is this guy right here, and that does require all 3 wires. Only thing that does and doesn't is the bed, and that's only because it's actually going in multiple directions at the same time. The solid state relay is actually only controlling your line level power. It doesn't care about your neutral or your ground. The ground for the bed be attached directly to the bed, and the bed is mechanically attached to the rest of the printer. So that should provide a decent ground to the whole printer. Should. And last one here on the ground. There we go. All right. Let's quickly heat shrink these. Maybe if I can get them on. There we go. There we go. And this one's all the way back here. So I mentioned at the beginning, I'll mention it again. I mentioned it a couple times throughout. If you haven't subscribed, please do so. Ring that bell to get notifications when I launch out new videos. I do have enough subscribers now to do some live stuff here and there. I held off on doing very much of that just because, well, wasn't sure if anybody would show up. So now that I have a little bit of an audience, I'm going to try to get some of those out there. It's finding the time to do them. I do these live in the sense that I'm building it without editing, but find the time to actually do a live stream and chat at the same time is a little bit more difficult. All right, so these terminals are actually facing upwards. So they are tight. There we go. There's that. And let's see here. Our neutral. That. And let's end it with our line right there. So I'm already planning on building another Voron kit. I have to say it's kind of addicting. So I'm looking for input on what people would like to see. Right now I'm kind of thinking, I've seen the new Trident. If you haven't seen that, take a look at that. I'm thinking of a version 1 of some sort or 0. Actually lean towards a 0, I think. But if you have any input, be happy to hear what you guys like to see. I hear that, or hear and have read that they kind of all have a lot of similarities. So I think when I do another, I'm going to leave a little bit of extra length here on this wire. Not a ton, but enough that I could pull it out without having to wrestle with it. I do another, when I do another, probably would like to do a marathon build, which is another reason why I'm considering the Zero. I'm also thinking the Zero would be good for the kids when they want to print little doodads. One of the favorite things that they like to do and have is, actually it's real simple. We basically take a 2D drawing, either a logo like their school logo or mascot, or something along those lines, and then convert it to a black and white grayscale, maybe modify it slightly, but then import that into Cura and convert it to a 3D G-code so they can print off little tags for their backpacks, and then possibly even customize them with initials or the year or something like that. We've done that a couple times now. Made some gifts for kids at the end of the year last year. So, oh, darn it, I was gonna use that blue one, wasn't I? I may have messed up. So I think a Zero would be great for that. I don't know if it'd be any easier for them to use, but I guess that works. But seems like a good use. All right. Well, that looks wonky, doesn't it? All right. So at this point, we have our mains power coming in, going to our 24 volt, going to our 5 volt, and then going over to our solid state relay, which will be controlled by our control board. So basically there's going to be an input, a low voltage input that comes into here that turns this on and off. That is going to control whether or not the current flows from here out to this pin, and then from this pin out to the actual the heated bed. Before going further, I'm going to show you guys something about this. It's probably overkill, but worth a mention. Might save somebody a headache. I'm going to power this. This is live. So, that being said, you need to be really careful. So, powering this up, I'm going to have live power in here. At this point, up until this point, nothing's been live, but there will be live electricity in here. So this is where you want to get really careful with everything. So my light on my switch has just come on. So I know it has power. And we're going to go ahead and do some testing here of our voltages. I'm going to switch it from DC to AC real quick. And I don't know how well it's going to show up on camera. But so first things first, we're going to test our power coming in. So we're going to go from line to neutral. And I have nothing right now, which means that the power's turned off. One quick note, make sure you do not touch any metal portions of anything with either of your probes. I'm going to turn it on. There we go. So my voltage coming in right now is at 122.1 volts. So it's going from here, and then it's working its way over to our 5 volt, which is showing the same. And then last but not least, we'll hit our lead there and our neutral here. And about the same there as well. Okay, so we know we have our AC voltage good, and we know it's flowing through everything it needs to flow through, and those are the only components that really is going to flow through other than the bed, which is going to get powered by that relay. So at this point, I'm going to switch this over to DC. And we want to confirm that we're actually getting 24 volts out of the 24 power supply. Like I mentioned before, there is a pot or a potentiometer right here that would allow you to adjust the voltage if you had to. So I'm gonna go red to positive, black to negative, and we're at 24.05. And just to show you what that adjustment would look like, I will mess with this. So we're at 25, 26, probably easily go to 27, 28 volts. So I'm going to adjust it back down to 25. And then quick thing about voltages on these DC regulators. If you're within 10%, you're pretty good. So 10%, and I would say prefer 10% over versus 10% under. Reason being is DC voltage does drop over a run a lot more than AC voltage. It's one of the reasons why we use AC. So yeah, so we got 24 out of there. That's fine. We got 3 inputs. They're all on a single rail, so I don't need to test every single one of them. So now we're going to test our 5 volt. And 5.04. Okay, so we're good there as well. So all of our voltages check out. Oop. And I'll do one last thing. Switch that back to AC. We'll make sure that the switch is working properly. Oh, look. Whoa! Sparks fly! Knew something was going to happen. So pull that out. We probably blew the fuse. Well, guess that's a great time to end this video. I'm going to find out what we broke. Hopefully it's not much. And wrap this one up and come out for the next one. Like I said, make sure you don't touch your components when you're doing testing, or else you'll wind up with the same thing. So anyways, subscribe if you haven't. I'll see you next episode. Hopefully whatever I did mess up, I can get replaced quickly. And subscribe. Thanks.